Hello everyone, my name is Alvaro, and in this video I will be solving another problem from the blind Leetcode 75 problem list. Today I will be doing problem 70, which is called climbing stairs, and it's the first dynamic programming problem that I'll solve in the channel. So let's get to it. You are climbing a staircase. It takes n steps to reach the top. Each time you can either climb 1 or 2 steps. In how many distinct ways can you climb to the top? Example 1, you have an input, which is n equals 2, and the output is 2, because there are two ways to get to staircase 2. You can either take 1 step and 1 step, or you can take 2 steps. For 3, there are 3 ways to climb to the top, just 1 step, 1 step, 1 step, 1 step and 2 steps, or 2 steps and 1 step. And the idea is just to find what the output would be for any number, n. So if you want to try this problem by yourself, now would be the time to pause the video because I'm gonna go over how to do this. All right. So for starters, I think we're gonna do n equals 4, and I think this will illustrate a bit what this problem is about. So for n equals 4, we can either take 1 step, 1 step, 1 step, and 1 step. We can take 1 step, 1 step, and 2 steps. We can take 1 step, 2 steps, and 1 step. And then we can also take 2 steps, 1 step, 1 step, and 2 steps, and 2 steps. So those are 5 unique ways of getting to the top. Distinct ways as well. Distinct, unique, the same thing. So if you want to take a little bit and try and find a pattern between this and that, feel free to pause the video because I'm going to explain the relationship. So as we can read in the problem statement, right, it says that each time you can either climb 1 or 2 steps. Therefore, it follows that to get to the nth step, you either have to come from the nth minus 1 step and take 1 step to get there, or come from the n minus 2 step and take 2 steps to get there. And if we look at all the different ways here, right, what I said before, this would mean that you can either come from third step and take 1 step, or you can come from the second step and take 2 steps, because n minus 1 is 3 and n minus 2 is 2. And if you actually take a look at all these, you'll realize, for example, if we exclude the last number in each row, you can see that this line here corresponds to line 1 in example 2. 1 step, 1 step, 1 step. So this one right here corresponds with this. 1, 1, 2, if we exclude the last one, corresponds to line 1 in example 1. Then this one, 1, 2, corresponds to line 2 in example 2. This one right here corresponds to line 3 in example 2. And this one right here corresponds to line 2 in example 1. And if you take a look at all this, right, so if we can actually regroup them together, what we can see is that example 1 represents n equal 2. So this would be n equals 2, right? And this is n equals 3. So as we can see, right, in n equals 3, we take 1 step. So that will be the last one. So it will be this one, and this one. And for n equals 2, we take 2 steps. So the last element in the row is a 2. So it checks out. Therefore, it follows that the number of steps for step n is equal to the sum of the number of steps for step n minus 1 plus the number of steps for step n minus 2. And that will be the recursive relationship that solves this problem. And if you actually realize this, this is just a Fibonacci sequence. You know, the sum of a number is equal to the sum of the 2 previous numbers that come in the sequence. So now the actual question comes, can we compute the Fibonacci sequence in a effective, in a nice time complexity? And the answer to that is yes. Obviously, if you just define a regular recursive relationship, with just the base case being n, you'll end up branching so many times that the runtime will end up being like big O of 2 to the n, which is quite horrible and not efficient at all. But if you take a step back and actually like think about what you need to compute at each time, we can actually manage to compute the Fibonacci number in order big O of n. There are also like mathematical formulas and like ways to compute this in big O of log n, but usually, like generally speaking, like in a ComSci interview, they will not be testing your mathematical knowledge that way. But if you're interviewing for a quant fund and all that, perhaps, but you'll probably be asked a much more difficult question than this in those cases anyways. So big O of n, the big O of n solution will suffice. And what is the idea behind this? Well, the idea, right, is that at any point, so to compute the number of steps necessary to take at step n, we need to know the previous one and the previous before that. And we can simply use two variables for that. We can use a variable to represent this and a variable to represent that. And then we add these two together, store this in some sort of temporary variable, and then just keep updating these variables as we go. And that's what we're going to do with this solution. So, excuse me. Let's think of the base cases. So the main base case, right, is if n is equal to 1, then we will return 1 because there's only one way to get to the first step, and that's to simply be there. And now we can create two temporary variables. I'm going to call this -1 and -2. So this one right here will represent n-1, and the other one will represent n-2. n-1 in this case will be a 2, and -2 will be a 1. And the main idea here is that we're going to start iterating at I equals 3. And we're going to run a while loop until it reaches n included. So what are we going to do? Well, we're going to define this formula right here. So temp is equal to -1 plus -2. So temp being n for the number, so the numbers step n will be temp, and then -1 will be step n-1, and step n2 will be represented by -2. And what do we want to do now? Well, we've calculated already step n. So what we want to make now is we want to make this right here take this value, and after we want to make this take this value. So -2 is equal to -1, and now -1 will store the temporary value. And as a result, whenever we're done with the loop, -1 will be the variable that stores the value temp. So that simply will be the one that we return. And then I forgot to increase the counter by 1. We definitely want to use this, otherwise the loop will run forever. But yes, this should solve the problem. Let's see, none of this is commented. Great. Yeah, so let's submit it. And with enough runtimes, it beats most of the solutions, as you can see here. 14 milliseconds down there. There you go, 7 milliseconds. And yeah, that's pretty much it. As I discussed before, the runtime of this solution is big O of n. And because, we go from I equals 0 up to n. So where n is the number that's given to us. And then the space-time complexity is big O of 1 because we're simply using two variables to store information, and that's it. And yeah, that's pretty much it. I hope you liked the video. Make sure you drop a like if it was helpful, and see you in the next one. Bye-bye.